On behalf of mothers and grandmothers who appreciate her life's work, and to publicly acknowledge her recent receipt of the very prestigious Heinz Award for her work on environmental health. Dr. Steingraber is a scholar in residence at Ithaca College and has a doctorate in biology from the University of Michigan, as well as a master's in English from Illinois State University. She's an ecologist and cancer survivor who studies the impacts of environmental toxins on human health. In her book and film, her great book and film, Living Downstream, Dr. Steingraber documented her personal experiences with cancer and the chemical contamination in our air, water, and land. Over the past year, she has been exploring hydraulic fracturing for a column in Orion magazine, as well as in her forthcoming book on environmental threats to children's development. She has recently returned from a 20-state tour researching the effects of hydrofracking on communities through the United States, and we're very lucky to have Dr. Sandra Steingraber.
Well, it's an incredible honor to be here. You have a beautiful community, and I was admiring the flowers before I knew they were for me. Thank you. Thank you. So I'm not going to show you slides, but I do have some audio, some visual aids I'm going to bring out in a minute. But what I want to do first is to take you on a journey to a place that you can't see. There are no PowerPoint presentations of this place. And it's the subterranean landscape below our feet, the Marcellus Shale itself. So let's start there. 500 million years ago, upstate New York was a shallow ocean full of sea lilies and squids. And when these creatures died, they sank into the sediments of the seafloor and became bubbles of methane. And there was a reason for that. There was a certain amount of oxygen in the atmosphere at the time, but there were no land plants yet. This predated all the trees that we just learned a lot about. And so because there's not enough oxygen, their bodies wouldn't decompose the way ours did. So that's why they ended up as methane bubbles instead of rotting the way things do now. So to the east of the shallow ocean, there was a large mountain range where the Catskills are now. And that mountain range entirely eroded into the ocean. And mountains, contain a lot of elements inside of them. And all those elements eroded with the silt into this inland ocean. And some of those are arsenic and lead, mercury, and strontium, which is radioactive. And they also became part of this seafloor. So as all of those particles of silt, dust is called silt when you add it to water, but it's the same stuff. So all this dust fell into the ocean, and as long as the ocean is very still, which this ocean was, the dust will settle out as silt, land on top of those methane bubbles and all those heavy metals, and then get pressed into shale. So that's how we came to have this Marcellus Shale under our feet. It lies down there about a mile below us. So it's a kind of petrified fizz of champagne bubbles trapped in rock that's suffused with the salty brine, the original salt water of the ocean, but which has now had a chance to concentrate. So it's 17 times more salty than ocean water, and all these kind of metals and radioactive isotopes. As long as we leave all that intact, it's not hurting anybody. Although it does contribute radon to our basements. As you know, the Marcellus Shale is a kind of a radon-intensive area. And so we have to do things even a mile above to sort of mitigate the radon that kind of comes up from this thing. But other than that, it's mostly, it's our bedrock. It's our kind of subterranean national landscape. And if we use water and toxic chemicals as a club to shatter it, in order to bring those bubbles of gas to the surface, we really do open a Pandora's box. So you heard about some of the ecological effects, what will happen to our landscape if it's industrialized. And I want to talk to you now about some of the health effects to ourselves. The Marcellus Shale is alive. It's full of organisms, very strange organisms, some of which have arsenic in their DNA instead of phosphorus. And these organisms in general are called extremophiles. They're able to live at very salty conditions, very hot conditions, very acidic conditions, and so forth. So the Marcellus Shale is really more like a coral reef than it is kind of an inert bunch of rocks down there. And all of these organisms, geologists now call deep life. That's the sort of generic name for them all. Only in the last year have geologists fully appreciated that in terms of just sheer biomass. They suspect now that there are more living organisms in the deep geological strata under our feet than there are in the world's oceans. So they're talking about a lot of living things down there. And these things are, take the form of fungus and bacteria and things that don't even have categories on the surface. So the old idea that the living world only exists on the surface of the earth and that underneath the earth is just kind of dead, inert, elemental stuff is not true, as we now know. And the reason I think that's important for us in terms of a conversation about health is because it explains why these powerful poisons have to be used to get the bubbles of gas out. Like, why couldn't you just use fresh water as under tremendous amounts of pressure and just blow up the shale and get the gas out? Well, first of all, there's a lot of friction, so you need surfactants. But why does it have to be so poisonous? And the answer is you need biocides. You need poisons to kill off all those organisms, because otherwise they slime up the pipes and they inhibit the flow of gas. So one of the main reasons that so many really toxic chemicals, the carcinogens, the things that in pregnancies, things that are associated with brain damage, things that can make you infertile, the reason they have to be used is because the Marcellus Shale is alive.